Okay, so our goal here is to approximate the total change which is this thing. The total change in h, here we have the graph of h prime. So we want to approximate the total change in h, change h, over the interval 0.51. Okay. So that's what we want to do. We want to approximate this total change. We can approximate it using a left-hand endpoint approximation, or we can approximate it using a right-hand endpoint approximation. Now the total change in h is literally equal to the area. This is the area between h prime of t and the t-axis over the interval 0.5, 1.0. Okay. So the actual total change in h is you could think of it as an area, okay? It's this area. Let me draw it in. That wasn't really a straight line, is it? Let me move this up a little bit. There we go. It's all this space. So this area here, that area, that red area, that whatever that area is, right? You can see that it's not a rectangle, so it's going to be kind of hard to figure out that area. Whatever that area is, that is the total change in h, and that's what we're going to approximate with rectangles. Okay. So keep that in mind, that this red area is exactly what we want to approximate with rectangles. Notice that it is a curvy area, right? It's not an exact rectangle, so we can't just multiply length times width to get its area, but we can approximate it with rectangles. Okay, so first using the left-hand endpoint. The left-hand endpoint, this is of our interval, so the left-hand endpoint of the interval 0.51 is 0.5. Okay, so using that, we look at what is h prime of 0.5, it's 3, and that's where we draw our rectangle. Okay. So the left-hand endpoint approximation is the area of this purple rectangle. Okay, that's length times width. Okay, so let's see. So the height of our rectangle is 3, right? It's 3. And the width of our rectangle is 0.5, otherwise known as 1.0 minus 0.5. So that's 3 times 0.5. So basically that's 1/2 of 3, which is 1.5. So our left-hand endpoint approximation of this red area is 1.5. Okay, now let's do the right-hand endpoint. The right-hand endpoint of 0.5, 1.0 is 1.0. So we take the height to be h prime of 1.0, which is this height. Okay, so the area of the green rectangle there is, the height is 4 times the width, 1.0 minus 0.5. 4 times 0.5. Okay, so you see that our left-hand endpoint approximation is the area of the purple that's less than, right? It's so a lot of the questions ask if it's an underestimate or an overestimate. You can see here visually that whatever the red area is, the purple rectangle, the left-hand endpoint approximation, is an underestimate. You can also see that the right-hand endpoint approximation is an overestimate. Okay. Now, keep in mind that this may not always be the case. It may not always be the case that the left-hand endpoint is an under approximation or less than the actual area. It may not always be the case that the right-hand endpoint is an overestimate or larger than the actual area. Let me show you an example. And notice the difference here. In my first drawing, h prime was increasing, right? It was an increasing function. Here, h prime is decreasing. So actual change or the exact change is this area here, right? This is delta H. This area here is delta H. Delta H equals this red area, okay? Okay, now the left-hand approximation, you can see, is an overestimate. It's bigger than the actual area. And the right-hand approximation, in this case, is an underestimate. It's smaller than the actual area.